So this could be facilitated by some drawing. Let's save this, and this is called belt thing. Yeah. So say that this is power and this is time. Well, right now I'm just drawing levels, so levels would be in green. So say this is 0. This is just the average value. Oh, you only can draw vertically? You're kidding. You are kidding. That's hilarious. Straight line. That's a funny icon. Okay. Okay. You click. Okay. So we call this the noise floor. Not the noise floor. This is 0. Okay. So I'm talking about the value of the audio in the audio buffer. Whether it's float or whether it's 16-bit integer, there's going to be a 0 value. And it's not likely that your sound will average out to that ever, unless you're using some kind of digital input. Now, there's going to be a noise floor, and this is the idle state. Yeah, whatever. So the noise floor, we can call it something like 20 decibels. Yeah, we can call it whatever we want. The thing is that it's not a straight line, and it's not something that's set in stone, so I can't write just 20 here. It's something that changes depending on where you are, where you happen to be, if there's air conditioner on your room. And there's a third level, and that's where you actually want to record. So record will be in blue. It's when you want to start recording. So this is when you say, I'm sure that we have meaningful input. And yes, it is possible for this line, for this kind of thing to happen, where the noise floor goes up above. This is what's happening right now in our application. So in that case, when this happens, so where's the eraser? There's got to be an eraser. I guess you just use this. Or you can use something like this. Oh, not the right thing. Yeah, anyway, it'll be a little bit like the Matrix or Tron. Yeah. What you really want is this kind of thing to happen. You want the onset time oops. Yeah, so this is noise floor. Put that in white. And it's also going to be start rec. Shoot. You have to press like enter, return, or something, space, I don't know. I think it's enter. I'll just press everything and we're good. Okay. Yeah, so you see the issue now. If we move now, the thing is, so these aren't actual signals. These are just the levels for application to trigger stuff. The thing is that we don't know, just starting up, if someone's talking to the microphone. And we don't know, for example, when it's quiet and then when I start talking, this is what the signal will do. It'll go like this. Or more likely spike up and then go like that. And if it spikes up like this, we correctly detect the onset and continue on. But if the noise floor slowly rises up like this, say, or it could also suddenly rise up, say someone is in a library and they open the door to outside and it's really noisy, or just somewhat noisy, then it'll do something like this. It'll look like the speech thing. So in that case, what we want to do, it's okay to output an onset here for that first time, but after a while we want to realize that the noise floor has risen and raise this up. So what we do is we can take a moving average of several values in time, and this will give this smooth curve. Yeah. Yeah. So what I didn't mention is there's also the release. There's also going to be a release value, and it's going to be kind of in between the two. So I'll draw that in pink, and that'll be like this. And that can also be computed the same way. So this system will pretty much get you what you need. And that's exactly what is in this code. I'm not sure why noise floor height is always 20. But you can see that never changes. But minrect dB does change. And it could be we use an even simpler system where we only change minrect dB. And let me search for minrect dB and see how many places it's used. It's used there. So this is the actual attack detection. Sorry. So what's interesting about this is that we set it to, it's going to be at least the noise floor, and this is just the constant value. And then on top of that, so we take this frame's average, it's computed up here, and we add that average to the amplitude that is the difference between in the decibel difference between the last min record dB I see. So this will keep rising pretty much. Or falling. Wait. Minrec dB. Calculate dynamic gate. Yeah. You know what? I'm going to look at one more source since we're being a little bit studious today. And it's one that I like a lot. And I just remembered. Oh, there's a lot more audiobooks here. Digital Audio Effects by, is it Udol Zolzer? Yeah, this is actually, the AFX is a convention. So this is written by several authors, edited by Zolzer. And basically it has all the like basic effects you would want. It doesn't get into like super fancy stuff, but a lot of cool like I don't know, effects you would see on a guitar pedal. So they have a noise gate, and that's the one I want to look at. Because a noise gate is pretty much what we're doing. So their formula for noise gate and I thought it was right here. Yeah, they've got a lot of cool distortion stuff in this chapter. Anyway, noise gate 102. Yeah. Really? Yeah, 102. Yeah, I think I've implemented this before. I don't know if this is a dynamic one or not. This is not dynamic. It takes in the attack and release value. Yeah. Yeah, well, you know, this is kind of a specific thing we're asking for here. So we should be prepared to get specific and write our own code and specify our own code. So what is this doing? Let's figure this out. Minrec dB. Because this code does work pretty well for as simple as it is. Alright, you know what? Minrec dB noise floor height dB. Yeah, so okay, let's imagine the first iteration where minrec dB is 40 for simplicity's sake and noise floor height dB is 20. So this value will come out to that this dB amp will evaluate 20 and it'll convert that to amplitude, so whatever amplitude